All right, well, go ahead and get started then. Hello all, my name is Corey. In my session, RIP passwords, farewell to our arch nemesis. I know we're all sick of passwords. Thousands of them in our keychains. We've reused them across multiple sites. They've leaked time and time again. So I'm gonna share some strategies that I've learned to help you get rid of them. So a little bit about who I am. Currently, I serve as a DevOps engineer on the M365 Platform Protect Blue team, what we call Assume Breach. And our job there is we assume that our infrastructure has been breached. We try to figure out how fast can we respond, how fast can we identify, and we build AI-powered intrusion detection systems to help us facilitate that. My background, I have an associate's degree in information technology from Kaplan University with an emphasis in cybersecurity. I've been in IT professionally for 15 years now. Started out as a PC LAN analyst, worked in data centers, helped Microsoft build out some of the initial Azure data centers. Well, one of the initial Azure data centers in Iowa, the central US region. I did a lot of server rack and stacking, network engineering there and all that good stuff. I spent a few years as a network engineer in the insurance industry. I was a systems administrator for a few years, and then I became a full stack developer for about 5-6 years, mainly in .NET. I did some COBOL, front end, back end, SQL, all that good stuff. Currently, I hold actually 4 Azure certifications: the Azure Fundamentals, the Administrator Associate, I'm a DevOps expert, and the Cloud Solutions Architect expert. And so I really like to think macro, big systems. I like to kind of keep things up and running, do build and release pipelines, all that good stuff. And so yeah, that's who I am. Primarily my background and my training is actually more in network engineering and security and stuff. And so that's kind of really my focus. So I wanted to start a brief history of passwords. They started at MIT in 1959. They created this compatible time-sharing system, which was the first concept of a user password login mechanism. In 1972, cryptographer Robert Morris came up with an encryption process known as hashing. Then they created salting, and this became the initial encryption mechanisms around passwords. AT&T actually secured the patent for two-factor authentication in 1998. I did not know that. So I'm sure you guys use 2FA now. Hopefully, if you're not, you should be using it. And then in 2003, Philip Oechlin came out with this concept of rainbow tables. Anybody heard of rainbow tables? You have? Yeah. Rainbow tables are good. So rainbow tables takes an algorithm and calculates every single possibility based on the character set and stores them in a table. And instead of trying to decrypt the algorithm, it just matches a hash. And so it speeds up your ability to decrypt things a lot faster. And then they call that time memory trade-off. And so, lots of memory, less time, and so it speeds up the process a lot. And then a little fun fact, in 2022, 24 billion passwords were leaked. 6.7 billion of those were unique pairing of username and passwords. So the vast majority of them were reused across sites. And I'm sure all of us are guilty of that. Let's talk about how we currently store some passwords and just kind of work through this and build up on it. So for users, we typically keep them in a keychain, right? You have iCloud, you have your Linux keychain, you have your Windows password vault manager, et cetera, et cetera. For your applications, typically you'll use like a key vault manager, whether it's HashiCorp, Azure Key Vault, AWS Secrets Manager, and then you have your password managers like LastPass, LogMeIn, and all that stuff. And I always like this meme. I created this meme, and it's kind of funny because you have, your key vault, and you have all these secure passwords, and it's protected by a very weak password that's probably compromised or leaked somewhere that you can remember to be able to access it. And so it's almost like putting everything in your garage and then leaving it open, And so it's a big problem because at some point in the chain with passwords, there's a weak password that someone can remember, otherwise you'll be in a world of trouble. And so cracking passwords, when I first got interested in hacking, I was probably around 11 or 12. There was a program, John the Ripper, and Cain and Abel, and you could use these to brute force and crack passwords. And at the time, in 1999, I was 11 years old. It would have took 951 years to crack an 8-character password using upper, lowercase, and a special character. Now we can do that in about 5 minutes. So that goes to show the exponential growth, right? And now we have cloud computing, now we have quantum computing, hyperscale computing, and all these things to make it even worse, right? And I just kind of came to this conclusion that passwords are just useless now. They're just not secure anymore. Our computational power has surpassed any type of encryption that these passwords could provide for us, and so it's just, I don't know, it just kind of became an invaluable thing. So to back up a little bit and kind of give you some context on why I'm doing this session. So at Microsoft, one of the things that we had a lot of front page hacks. People were leaking credentials, secrets, all that stuff. And so they created the Secure Future Initiative. And my role in on this was across all these different Azure resources, how do we get rid of manually managed credentials? That's certificates that need to be rotated by hand, that's passwords that we need to rotate and store somewhere. Anything, any type of credential that you have to go and manually manage, we want to get rid of them. We don't want any of them. Developers have more important things to worry about. And so in this initiative, I've spent a lot of time working on a lot of very complex authentication scenarios across different products and resources, and implementing new authentication methods that have not been released yet, and we're kind of dogfooding them to push them out. And I've developed a lot of knowledge. I've been working on this project for about 3 years now, maybe a little over 3 years, maybe 3 to 4 years. So so that's what inspired this. And one thing I've learned, and I'm reading over this stuff and I'm studying this, and I'm like, it's easy to crack your passwords. It's even easier to steal your passwords, And so in 2022, over 24 billion passwords were stolen, not cracked, not leaked, stolen. More than 80% of the confirmed breaches were related to stolen, weak, or reused credentials. 8 out of 10 security breaches because of passwords. Users who don't use password managers are 3 times more likely to be victims of identity theft. And 89% of people realize that using the same password is a security risk, but only 12% of them switch passwords between accounts. And it's like, let's be honest, how many accounts do you have on the internet? I probably have an account to everything. You can look at my keychain. And this is kind of one of the things that kind of cracked me up, because it's like, in your keychain, it tells you, so it tells you like, compromised passwords, reused passwords, all that stuff. And it's like, yeah, I could go, but like, look how many accounts there are. I have so many accounts to so many things. I can't think of that many passwords. I even, and I could do random strings and all that stuff, and it's just too much. It's annoying, and they just need to just go away. Look, I have 378 passwords. That's just for my personal account. That's not even my work stuff or anything else. That's just my personal. 378, one person. Most of those are going to be leaked. I got a third of them leaked. And it's annoying. There's too many. So, so what options do we have for authentication besides passwords? There's a lot of new technology out. FIDO Institute came out with passkeys. I'm a huge fan of passkeys, and I think that they should be the default because they generate a stronger encryption signature than any password complexity policy that we could create. And then there's one-time codes. I'm a big fan of that. We'll send a code to your email. You'll log into your email, and then you'll use the code. Certificates. I've had a lot of trouble with certificates over the years. They've caused me a lot of pain, but they are necessary, and there are methods to make them so that you do not have to manually manage that. And I will share that, and I will share some information on that with you as well. UB keys, has anybody used a UB key before? You guys all got UB keys? Cool, cool. And then magic links, which those kind of make me nervous, but they're good. It's better than having a password. You know, and it's like, you know, so I've said some of these things before, but like, why should you avoid manually managing credentials where possible? There's just way too many to manage. As your systems get bigger and you scale out, you're just going to add more passwords. You have, if your business is going right, you're going to have more users, and they're going to need more passwords. And you know, the likelihood of proper management is extremely low. Out of curiosity, are you guys developers, or what type of capacity y'all operate in tech?
Test engineer.
You're a test engineer? Development? Data engineer? How many of y'all spend time in your sprint properly managing your credentials?
Properly?
Yeah. Because management doesn't measure developers by that, right? How fast can you get your feature done? You know? You said what?
You're good enough.
Yeah, you know, I mean, you know, yeah, you know, at least you didn't know you were hacked. You know, they're likely to be leaked, and expired credentials could cause systems to fail. That is something that I've experienced a lot, where certificates expire, passwords expire. You forgot that you even put this in place however long ago. No one got the person who got the email, they left the company, nobody knows, and you got to hunt it down and figure it out. You know, so I just like to just get rid of them. And there's two parts to authentication, right? There's client side and there's server side. And I want to start with the client side authentication, because I think that that's where a lot of our publicly leaked credentials come from. You know, you have to create an account to every single website to look at all this free stuff. You know, they should probably do some legislation to prevent that, but that's a whole different topic. And so on the client side, I wanted to present a few different methods. You know, WebAuthn, which does passkeys. You know, it's really nice. It's really easy. It's a simple JavaScript library you can throw in your site. It's really nice. This is for client side. FIDO passkeys are really good. The passkeys are nice because you can put them in a password manager. They are not exportable. They are not stealable. And so you can make them device specific, you can make them user specific. So if you have a passkey in your iCloud, he cannot put it into his iCloud and use it. You know, but you could you could use it on your iPhone and your MacBook or wherever you're logged in, you know, so it's more than just username and password, it's device and a lot of other criteria that get baked into the encryption to make it more secure so that it can't be stolen as of yet. I'm sure somebody will figure out a way. Microsoft Authenticator, sure a lot of people use that. You know, send code to email, send SMS to phone, the magic link, and then application identities. And application identities are nice because, you know, you log into something, it's like, yeah, you want to give your account permission to this, you know, and it binds that OAuth flow for you and takes care of that. And that way there's no manually managed credentials for you. And so wanted to dig in a little bit into this WebAuthn standard. WebAuthn was created by the W3C, which is the the Worldwide Web Consortium, and the FIDO Alliance in 2019. It is supported by all major browsers, and it uses a private key, public key validation similar to X509 certificates. And it's really nice because it just takes out, it uses your device's biometrics. There's nothing to it. It just works very well. In my personal opinion, I think that this is the best one for client-side auth because it's just so easy to implement and integrate. And so how the registration flow works is you have a replying party server that runs in a Java application in your browser. And the client initiates a request to register the authenticator, and it builds a public key credential. The browser validates the ID, and then the JavaScript client creates a credential hash for client data. authenticator will ask the user to consent and register the credential object. The authenticator takes the credential object and registers it a new pair. It returns a public key, credential ID, and other data. And then the response is validated and the public key credential is returned to the reply server to complete the registration, and then you're validated. Any questions, concerns there? Pretty straightforward. That's why I like it. It just works, you know, they did a good job on that. And then the authentication flow is very similar. Is just using, instead of creating the public key, it's just validating it, is really the difference there. And this is very quick, and it's client-side. It happens in your browser. And so this is a very nice, simple authentication flow that should work for most websites or user-facing applications where a user logs in. It allows them to use device biometrics, which provides you some multi-factor authentication. It has a stronger authentication flow with the passkeys and stuff, and it generates a stronger encryption algorithm than what you would with your passwords. And so that's something I highly recommend you looking into. FIDO passkeys. I just love passkeys. They're just great. I put this little video in here. I'm gonna play it for y'all real quick.
Look at these poor souls. Stuck, trying to remember their passwords. If only there was a way that didn't involve 12 to 16 upper and lowercase letters, numbers, and special characters. Oh wait, there is. Passkeys. Passkeys make signing into your favorite websites fast, simple, and secure. And can be used on most of your devices, even when you get a new one. You can even sign into your account from a nearby device. So you can get right back to shopping, espresso machine, I'll take a double, selling, I don't know what you're selling, but I'm buying, listening, country fan, huh? Well, idiot. And streaming. Spoiler alert, just kidding. Easy, right? Learn how to get passkeys for your apps and websites at passkeyscentral.org. Shh. Oh, sorry, my bad. Free yourself with passkeys.
Never seen a commercial about such a thing before, so I was amused by that and wanted to add that in there. So, come back here. Yep, and so a passkey is the actual authentication or the encryption component. They can be on YubiKeys, they can be on your devices, you can put them in password managers. You know, they're very robust and widely supported. I haven't came across too many major sites or services that don't use them nowadays or support them. You know, a passkey is an authentication credential based on FIDO standards. It allows users to sign in, you know, and use their device, you know, as a biometrics. The FIDO cryptographic credentials that are tied to a user's account on a website or application. With passkeys, users no longer need to enter usernames and all that good stuff. They can be synced or device bound, right? So you can say, oh, nope, this passkey can only be used on this device or this YubiKey or whatever. You can say, yeah, as long as this user's logged in, you know, they can use it wherever they want to. And like I said, it's supported on most major password managers. Microsoft Authenticator, anybody use Authenticator? Yeah, we all do. They got us all. It's a very interesting one. It's kind of a password manager, an authenticator, and M2FA all in one. It's a very robust application. But it's kind of that same flow, you know, the user, you know, going over this flow and how it works, you know, the user enters their username, they log in, the Entra ID detects that the user has a strong credential and starts the credential flow. That's where a notification is sent via push notification or Firebase cloud messaging, you know, to pop up, you know, and then that's when you pick your number, make sure it matches, you know, all that good stuff. And then the user completes the challenge by entering their biometric or PIN to unlock the private key. The nonce is signed and the private key is sent back to the Microsoft Entra ID. Entra ID performs public-private key validation and returns a token. Any questions on that? Thoughts? Well, pretty straightforward. And then another one is passwordless sign-in with email. And this is just you pretty much straightforward. Get your email. It sends a code, a one-time password. You put that in. That's how you log in instead of using a password. The goal here is to, at least from a developer perspective, removing the liability of you having to manage a database with hashes and salts and user credentials and all that stuff, you know, and taking that off of your plate and putting it back on the user by making them go through another account that they have access to be able to get this one-time code. And then they get that one-time code and use it to log into your system. So it's a form of multi-factor authentication, right? Because you got to verify that you own this email by being able to access it to be able to get this code, you know, and it takes the liability off of your team and your product and having to deal with managing all that stuff on your end. You know, you can get rid of your user databases and all that stuff and let them take care of it. You know, so just offsetting that liability. One of the products that I use in my personal projects for this is Auth0, which I will get into that a little bit later. You know, the flow is pretty straightforward. You know, user enters email, application sends an email with the code, Auth0 sends the code, user enters code, application sends a code to Auth0, user's logged in, authentication flow is successful. Same flow with SMS. The only difference is just sending a text message instead of a code to your email. And to do it with SMS, you do need a provider like Twilio, which you got a registered number with them and go through their whole little process. But that's another method to be able to provide client-side authentication without passwords to your users. The flow is exactly the same with the exception of adding Twilio in there. To actually send out the message, or if you have your own provider, you can do that as well. You know, and then magic links, it's the same thing. It just sends a magic link instead. One of my favorite ones is application identities, and these are kind of complex to work with and reason about. At least for me in the beginning, I had a very hard time reasoning about this. It's essentially a user account for your application. And it allows you to give your application the same identities and properties that you would give to a user. And it has cryptographic signatures that have immutable properties that cannot change. One of the best explanations that I read about it was from Harvey Sverdlov from Zscaler in his blog. And the 4 characteristics that he put were that they have unchanging characteristics, they're understandable characteristics, a broad variety of characteristics, and upgrade tolerance, meaning that you can add stuff without breaking what you already had, changing properties and stuff, but then some of the properties you cannot change. You know, and so these application identities are a way to authenticate and give application role-based access control. Instead of granularly just giving username and passwords to be able to access different systems. Anyone here work with IAM, Identity Access Management? Yeah, so if you're familiar with RBAC, you know, this is a way to give RBAC permissions to your applications, which is a nice part of the flow. And so any questions about the client-side authentication? No? All right. So for server-side authentication, this is where things get interesting. You know, I'm sure you guys have lots of servers that talk to servers that talk to servers. So for the server-side authentication, there's 4 main ones that I found are super valuable. I had 10 on my list, but I wanted to narrow it down to 4. The newest one is a federated identity credential. This is the latest and greatest in security. And then there's managed identities, which managed identity is a Azure-specific technology. AWS has, I think it's called a secrets identity, or something very similar. I forget the name of it. And then an Entra app registration, which is essentially an application identity. And then Auth0 has a machine-to-machine identity, which I thought was pretty cool and definitely worth mentioning. And so these are back-end server-to-server authentication pieces that we're going to dig into a little bit deeper. The federated identity credentials are a new type of credentials that enables workload identity federation for software workloads. Do any of you guys have like hybrid environments where you have some on-prem, some in the cloud, or all cloud or all on-prem? No cloud, no on-prem? So with these federated identity credentials, what it allows you to do is it allows you to bind identities together and create these combinations of identities where you are able to federate across workloads and services in your environments in a manner where you're using OAuth instead of passwords and username and passwords. They work in the cloud, they work on premises or hybrid to securely authenticate and access resources in another environment without requiring long-lived credentials like passwords or access keys. So those are new. I think those were released maybe a year ago. So they're like very, very new. They're very interesting. I'd recommend you look into them. And so just kind of show you how it works. It uses a claim-based access control model. Your service outsources the authentication to an identity provider or security token service. And your consumer caller authentication requests your token to service. Consumer caller sends tokens to your service auth. Your CBAC model uses audiences to provide granular access controls. Claims can be used to manage RBAC roles for services. Has anybody worked with this kind of stuff? Yeah, so Matt was one of my senior developers. Him and I worked on a lot of this stuff, and it was very, at least for me, it was very confusing. But as I got used to it and as I worked with it a little bit more, I realized that it's actually not that bad. It's actually, it's just a very different model. And the identity provider can be like, Azure, AWS, Auth0, and the value of using an identity provider here versus your own is these identity providers have a lot of security things that they build in the back end that provide you a lot of value that you don't have to manage yourself. So like, for example, with Azure, there's a lot of, it's called, I forget what it's called, but essentially they have tools where you can say, these devices can't log in. If you're not on this network, you can't log in. If they do AI risk score analysis to determine if there's a risk in your login, if there's unusual activity, and all these things that can help protect your systems that you don't have to bake in or build or focus on yourself. Conditional access control is what it's called. So based on these conditions, even if your authentication is successful, if you don't meet these conditional access controls, you still cannot log in. So you've probably tried to log into something. You say, yeah, it was successful, but you can't log in from here. So that's a conditional access control. So those identity providers can provide that. So some use cases for a federated identity is single sign-on in the enterprise, good for authenticating employees to services hosted outside of corporate security boundaries. User experience is same as application inside of corporate boundaries, and it uses a CIA method to provide access to other appropriate resources. They're really good with multiple partners, good for authenticating employees and partners that don't have accounts in your directory, and good for business-to-business scenarios. You got a new contracting firm that you're working with, but you don't want to onboard all their users. They already have their own directory set up. They already have their stuff. You can just use this to add them to yours, and they can authenticate. And when you're done with the contract, you cut it off, and then nothing's affected. You don't have to worry about dangling accounts and people having access and stuff that they're not supposed to. So it's a great way of managing is a great way of managing authentication while keeping directories and access separate from each other. And they're really good for SaaS applications, especially that support multiple tenants using a variety of identity providers or software vendors who provide multiple clients. You know, but there's always a time when you shouldn't be using these things. And two of those moments is when all users of the application can be authenticated by one identity provider, and there's no requirement to authenticate by using any other identity provider. And the application was originally built using a different authentication mechanism, perhaps with custom user stores, or it doesn't have the capability to handle the negotiation standards used by claims-based technologies. So if you have a system you got your own baked in username, passwords, you're storing them in your own database and hashing and salting and all that stuff, to switch over to a federated identity model would take a lot of effort. You would essentially have to rebuild your entire authentication control mechanisms. And so that can be valuable, depends on your situation. You have to evaluate that with your team and your products. And some reasons why you should use a federated identity is offloading user management and authentication shifts reliability for those components to the identity provider, which usually has a high SLO, probably much higher than what you're able to provide. Additionally, during workload disaster recovery, authentication components likely won't need to be addressed as a part of your workload recovery plan. Essentially, plausible deniability. And by externalizing user management and authentication, you can get evolved capabilities for identity-based threat detection and prevention without needing to implement these capabilities into your workload. You know, and so as they learn new things and they have issues with all their different customers and they build solutions to those problems, you get to inherently benefit from those. And when you offload user management and authentication, you can devote application resources to other priorities. You know, I know you guys like working with certificates and all that stuff, but, you know, we just want you to be able to get your features out as quickly as possible without having to worry about that. You know, one of my favorite things in Azure, and this is specific to Azure, is a managed identity. And I've been implementing these managed identities for about 2 years now. And I've had a lot of fun with them. They're very interesting. But there are some nuances with them. It's essentially an application identity that is managed wholly within Azure. There's no credentials, there's no passwords, you can't log in with them. They only work in Azure, and then, you know, but you can apply them RBAC and IAM policies just like you would any other user. The Azure Entra app registration, security groups, and RBAC controls can be used to supplement the developer workflow regarding authentication. And so what that means is you can have an application where in the cloud, it'll use these managed identities, but then locally when you're developing, you can use your local Azure credentials or your local developer credentials, and they can both have a set of RBAC controls applied to them that one's for the managed identity when the application's running, and then one's for the local development team when they're debugging locally. And so it really helps with the developer workflow and not having to log in, download certificates, you know, and all that good stuff. You know, and there's two types of managed identities in Azure. There's a system assigned and a user assigned. And the difference is a system assigned identity is one that is applied to the actual resource itself. It is an identity given to that resource, and when that resource is deleted, the identity is deleted. And so that's a way to make sure that you're not leaving gaps in your systems and open access to things that you don't intend to. And then the other one is a user-assigned identity, which is created separate from your resources. And it allows you to be able to use this identity across multiple resources and apply them in different areas depending on what your needs are. And so these managed identities are a way to authenticate to, like, you can SQL to, in my example here, I have a SQL connection to a web app service. And kind of how it works is on the code level, there's a default Azure credential. And it checks and it says, okay, if they're running in Azure, let's check to see if there's a managed identity. If they're not, let's go down the flow of, I think there's 9 different things that it checks for your authentication. And that makes it easier for you as a developer because there's no connection string to your SQL. There's no passwords, there's no usernames, or any of that. And so it makes the authentication flow really nice to work with. Managed identities work by providing a token service on the compute unit that the application can call to get off tokens. The tokens can be used by the default Azure credential object to create clients for SQL, Key Vault, Service Bus, or any service that supports managed identities, which I think now almost all Azure resources support it, if I remember correctly. Managed identities do not have credentials to manage, but they only work in Azure. And when using managed identities, developers cannot use them locally. And so that's kind of a nuance where now you kind of have to have 2 separate role-based access controls, one for out in the cloud and then one for when you're developing locally, which isn't too bad to work with, but it's just something to be aware of. And so these right now, especially in Azure, are the recommended path using these identities because they're just easy to work with and you don't have to worry about the managing credentials and all that stuff. The flow on these is a lot more complex than the other ones. And so, just kind of going over this flow. Does anybody work with Azure here? Yeah, just a couple of y'all. Anybody work with AWS? Yeah. So essentially, the flow here is you enable this managed identity on your Azure virtual machine, whether that's a system assigned or a user assigned. That creates a service principal and Entra ID. And that service principal is what is used to be able to authenticate and provide that user-based RBAC connection for the managed identities. When you update the IMDS with the new, which is the identity management service, with the new identity, the grant for the managed identity access to Azure resources services are based on RBAC. The request for the token is from the local endpoint, which on the actual virtual machine, there is a service that gets ran, and your application calls that service locally, and then that service reaches out to Entra, gets a token, and so that token service runs on your machine, and that's what provides the isolation, and that isolation prevents other people from being able to access that service to generate tokens outside of your virtual machine. One caveat is if somebody gets onto your virtual machine, then they can call that token service from a terminal or a PowerShell or whatever. Hopefully you have more security there to prevent that, and but it saves you a lot of time. It requests that token from Entra, and then that target resource using an Entra ID token, and then it authenticates to whatever service it needs to. Does that make sense? I feel like I kind of complicated that a little bit. Yeah. Yeah. But Entra app registrations, they're called Entra app registrations are Azure's version of an application identity. App registrations contain an app registration object and a service principal object, and they're bound together. You can have an app registration in one tenant that connects to a service principal across multiple tenants. And, there's some weird, complex authentication scenarios that might require it. But they can be used like users. And they almost show up in the directory. They look just like a user, and you can have names and properties and all that stuff. Authentication methods include passwords, certificates, federated identities, and now managed service identities, and subject name and issuer authentication. Passwords are still supported, but that support is not highly discouraged. hence the topic of this talk. They do fully support RBAC across services, and so you can apply role-based access control to these app registrations. And so the authentication flow here is users trying to access an application. The user successfully accesses the app. They're redirected to the Entra ID, and that's where it's like asks you to sign in with your email. You get the authenticator flow. It gives you your little number. You got to validate. It checks that against Entra and says, "Yep, they're good to go." And then and then your sign-in's complete. And then you can redirect back to like different identity providers. You can redirect back to auth callbacks where you handle these claims. And so there's a lot of flexibility there in your authentication flow. This example is a bit complex, but this example was actually from a project that I was working on, where I needed to have it redirect to this Phoenix ID, which is like this OIDC request service. And I was trying to see, essentially what it does is it adds an extra layer of security around the authentication piece. So your flow here is user tries to access the app, user is redirected to Entra to sign in, the user's authentication with the primary authentication method, usually Entra or a passkey or whatever the case may be. They're redirected to the Phoenix OIDC request. That Phoenix request, the user action for authentication, and that's where you say, do you want to give your user permission to this application, or give this application permission to your user? You say, yep, I give it permission. It says, okay, great. User executes the action, and then it redirects that back to Entra and says, yes, we have permission. Here's the claim from the user saying that we can do this. Entra says you're good to go. Now you have access. It's a pretty complex flow, huh? Lots of tokens exchanged, lots of claims being exchanged. It's an interesting process. But that's how, like, if you give your account access to like Xbox or Apple Music or whatever, and they ask you, do you want to give permission? That's kind of how that flow works here. One of the most interesting ones that I've worked with recently, and I've actually integrated this into a personal project that I've been working on, is Auth0 machine to machine. It's very similar to Entra app registrations. It's used for back-end to back-end connections, or application to service connections. Other authentication scenarios where authorized requests are not authorizing users directly, and machine to machine is really good for CLI applications and scripts. And so this is basically machine validating connection to machine. They both have signatures that they've approved of each other. And so here there are no credentials here. No, I stand corrected. It requires a certificate. So it does require a certificate that does get auto-rotated, and it's validated using subject name issuer. And so these are good if you're building a CLI application, some scripts that you want to run in your service. These are a great use case for those. And then, kind of going over that flow is very similar. Your application client's approved by the authorization server with Auth0. And then that claim token is used to connect to your API or whatever other machine that is trying to authenticate to. So it's a very simple, straightforward flow. Not a whole lot to it, not a lot of complexity there, unless you want to make it complex, as us developers like to do. And so yeah. And so those are the four flows that I have. And so I wanted to show an example. An example of using Yeah, actually, I'm not gonna do that here. I'll just show you. So an example of just using kind of this flow in an actual client-side application. And so there's a client that I built, sign in, and so I am using auth-O in this situation, and you can see that I have a couple of different things going on. There's full SSO integration, so I don't have to manage your credentials. You can log in with your Google account, your Microsoft account, or whatever. As you can see here, I have a pass key that's on my local device, and I can use my biometrics. But this one, instead of using that pass key, I have it actually using this code that it sends to my email. And you use that to log in, which now that you guys are here, it's not going to send it. In front of the company, it's going to embarrass me. But so this flow is using OAuth, and by not having these passwords into place, it allows me to get rid of my database on my back end. And on my back end, in my OAuth, there's an actual database for usernames, passwords, all that stuff. The problem is if that database leaks, then I'm liable for it. You guys could sue me. I might have to provide you identity theft protection, and all that stuff. And it offsets a lot of your liability. A lot of your management. You have more important things to build than to worry about user credentials and all that stuff. Let somebody else do it for you. It's worth the money, and so my email's not updating. So yeah, that's unfortunate that it embarrassed me like that in front of family. Yeah, there you go. But yeah, so that flow is pretty simple to implement with Auth0 and with Azure, and it's like. The thing that I realized is by getting rid of passwords and by getting rid of passwords, I can focus on actually building my software, which is important. I don't have to worry about leaked credentials. Anybody ever checked in the password into Git? Never? You never checked the password into Git? Not even once? You ever built any software? Oh, okay. Yeah, what's up? You have?
Once.
Once? Just once? Yeah, see, that's because he's a top tier engineer. I would do it every time if the policy didn't block me. So we have to put policies in place to stop people, to scan for those things and watch for those things, right? Because as developers, we're measured on how fast did you get your feature to production? Not did you follow OWASP top 10? Did you implement all the best security practices? Management's not asking you that in your reviews. How many features, raw numbers, how many features did you deliver? That's the only thing that matters. And so you want to do those things quickly as possible, which tends to make you cut corners. You don't have time to stop and evaluate what are the best practices nowadays. You just do what you know because you're comfortable with that. That allows you to move faster. And that can create problems for you down the road if you're not careful. And one thing I found is by removing these manually managed credentials, we've eliminated almost all of our outages. We used to have outages all the time. Passwords expired, certificates expired, they need to be rotated. Once I moved this, I worked on this project where we implemented managed identities and auto-rotating, I built this auto-rotation certificate framework where it would go in and automatically rotate the certificates and update all the thumbprints and all that stuff. 100% of outages eliminated because of that. It was crazy how often it was happening. We had so many certificates, so many user accounts, so many Entra IDs, and it just kept growing and it just kept increasing and it would never stop. And it was it was rough times, and I found that by doing this, you don't have to worry about that. That's one less thing on your plate, so you can focus on building your software. I've observed that when you have our base RBAC control for your software and your applications, and you have that flow for your developers, it's actually easier to onboard them because then you can just add them to a group. You get a new developer, you add them to a group, and then they have all the permissions they need for that application. You know, you don't have to worry about, oh, well, how do we get Jesse access to the SQL database? Well, who do we need to talk to get him access to Oracle? Well, why can't he log into this web application? You know, by using this RBAC access control versus usernames and passwords, you can create groups and apply those permissions to groups, throw your developer in the group, now he has access to manage this application. Now he has access to develop it. And so now onboarding goes from a week, 2 weeks, however long. I think for me to onboard and get everything working, it took 2.5 weeks to get my application working locally on my dev box. You know, now you just add them to the group, they got everything they need. And so it makes it a lot easier to manage that way. And it makes things secure, and it'll save you a lot of trouble. You know, I do hope that my session has been informative to y'all. And I hope you learned anything. Anyone have any questions, concerns? Yes, ma'am?
What's going to happen when quantum comes online?
So that's why I was talking about with the passwords, because, you know, even the long passwords, once we get quantum computers, that's going to take a few minutes now. You know what I mean? And I think that is going to change the, encryption alone will not be sufficient, you know, with quantum computing. I've already seen some studies where they're able to, they expect to be able to crack AES 256 within the next few years, according to MIT. And that's our default encryption algorithm now. So I don't know the full answer to that. I do know that all of our stuff that we have now is not going to be sufficient. You know, and that's where the multi-factor authentication comes in. You know, where just having a username and password is not sufficient. You need to know, it needs to also contain something that you know and something that you own, right? To kind of take it outside of the realm of just this encryption. So that's, right now, that's the best we have. But I actually have that same concern.
I've heard it term like store now, decrypt later.
Yes.
When, so many companies are right now storing data, whatever available.
Mm-hmm.
They want to decrypt it later. Right?
Yes.
Right tool is available, let's say, or something.
Yes. Yes. Yeah, between encryption and high performance compute, I'm not sure you ever heard of a company, APLD. They do high performance data centers. Their stock is booming. You know, I got in good on that one. But anyways, APLD, Applied Digital. And so they have these campuses where they do high performance compute and they lease that out. You can rent it as a service. And in these high performance compute environments, they are able to crack a lot of encryption. They have not fully cracked the AES 256, but they're working on it. And they, you know, with all these data centers and GPUs and stuff, any minute somebody could be like, yeah, we did it. And then all of our encryption for HTTPS and all of our bank accounts and all that stuff is no longer secure anymore. So I don't know what's next. You know, so that's interesting. Any other questions, thoughts, comments? Yeah?
What should you do if your password manager gets compromised?
If your password manager gets compromised, you're screwed. You know, and so, you know, from a developer perspective, right, I want to take that liability off of me and put that back onto you as a user. And so if you're using Apple, resetting your password, especially if you don't have a MacBook, is not a friendly process. Sometimes it can take like weeks and they have to do all kinds of stuff before they let you do it. It's really painful. But I would recommend that you secure your password manager and use one that is device bound. And then that way someone can't steal it, right? Because like, you know, with LastPass, if I get your username and password and all that stuff, then I can log into it. But with your iCloud, I can't. You know, because even if I have your username and password, it's not your device. You know, and so that blocks it, yeah?
You can't do that with LastPass because it'll email you asking if you will log in.
You say what?
Yeah, but if your LastPass password is compromised and you try to log in with it, it'll email you to tell you like, hey, do you want to allow this access?
Yeah. What if it's not compromised? Like, what if it's just like you just want to? If I just got your username and password, you didn't. Does it do that? Does it block you?
If it recognizes a new device login, it'll email you and notify you.
Oh, okay. Yeah.
So that's what.
Yeah. See, so like, with iCloud, it just won't even let you if it's not your device.
You can also do 2FA.
Oh, okay. Yeah. So there are some protections around them. I would recommend you look at what protections you have for your password manager, because I'm sure that they've all probably ran into this situation. Which one of them? One of them had a major breach recently. Was it?
LastPass.
Was it LastPass? Yeah.
It was everything else other than the password.
Yeah. Yeah.
It's the metadata.
Who owns LastPass now? Like, somebody bought them, and that's when I switched to Bitboard.
I'm not sure. Yeah. But yeah.
Why are passkeys pushed so much when NFA seems just as good?
Because passkeys provide a cryptographic signature that's very strong. And MFA is really good, but the passkeys allow that biometric access. And they can be device bound, which provides
I don't like that it can be device bound because the user or the creator can choose whether or not, or the site can choose whether or not to make it device bound. Is that correct?
Yes, that is correct. Usually like a device-bound passkey would be more like a FIDO, like a YubiKey or something like that. So there are some scenarios, right, where you don't want just anybody to be able to use the same signature as your YubiKey, right? You want only that YubiKey, that physical device. It's really more just the cryptographic signature is so strong, and as of yet, they cannot be stolen. So you cannot migrate the passkey out of my iCloud keychain into your LastPass, you cannot use that signature on a different device that's not authorized, and so it's one of those things where it's like right now it's the most secure thing we have for the time being, but yeah, I think that using that in combination with multi-factor auth provides an even richer level of security.
How do you do that? Because I thought it was one or the other.
Well, so it's kind of weird because it's like, if you log in with your passkey, right, you can have it registered, you can have it stored in like Authenticator, where you have it locked behind that biometric access to be able to use it. Or in iCloud, you got to have that biometric access to use it. So like even to use my passkey, I had to use my fingerprint scanner. So that biometric, it puts it behind that biometric access to be able to use the signature. But even if you were to get on the device and try to extract the signature itself and put it somewhere else, you wouldn't be able to use it. So that's how they kind of work together, if that makes sense. Yeah. By putting it in your Authenticator, your LastPass, or whatever your password manager is, it puts it behind that MFA. Any other questions? All right. Well, I thank you all for joining. I hope you learned a lot, and thank you.
Live in Georgia.
Who, me? Yeah.
Did you see what the Georgia security court system has done?
When Dulette gave, wait, what did they do?
They have, it's a good thing. They have a filing